This is part B of a question from the Rings, Polymers and Analysis part of the OCR June 2012 paper. And the question says, nylon 646 is a polyamide that can be prepared by reacting butane 1,4-diamine, that's that compound, butane because it has 4 carbons, with hexandioic acid. Hexandioic acid is hexane, because it has 1, 2, 3, 4, 5, 6 carbons. And it's a dioic acid because it has 2 carboxylic acid groups. It starts off by saying the diamine can be synthesized from 1,4-dichlorobutane, Cl, CH2 4 times Cl. Suggests the reagents and conditions for this synthesis. Well, if you look at the difference between your starting material and your product, the difference is that you're losing Cl and you're adding on NH2. So to do a nucleophilic substitution where you replace a chloride with an NH2, what you need is ammonia, but it has to be in ethanol. So that's written as NH3 ethanol or often ethanolic ammonia. The question goes on to say the H2NHCH2 4 times NH2, the butane 1,4-diamine, can act as a base and form salts with dilute acids. Explain how an amine can act as a base, and then write the form of the salt formed when the diamine reacts with an excess, in bold to remind us it's important, of dilute hydrochloric acid. So how can it act as a base? So a base is a proton acceptor. So the NH2 is a proton acceptor. That's how it acts as a base. And the form of the salt is, well, if you were to imagine, just look at the molecule like this, if that was just ammonia NH3, you would form NH4Cl. So we form NH3Cl with the rest of the molecule hanging on. So it'll be Cl minus, NH3 plus, so one of those protons comes from the dilute HCl, CH2 4 times, same with the other side, NH3 plus, Cl minus. The question then goes on to say, draw the repeat unit of nylon 46. And we're told at the beginning that nylon 46 is made from 2 compounds. It's made from the butane 1,4-diamine, so writing up here, H2N CH2 4 times NH2, and it's also made from hexandioic acid, which I'll keep in red, which is a dicarboxylic acid, CH2 4 times COOH. So what do we lose? It's a condensation polymer, so we're going to lose water. So we're going to lose water by splitting out, removing the water from the H2 of the amine and the H of the carboxylic acid, and then joining them up. So if we draw it this way, NH, CH2 4 times N, then what type of bond do we get? What we get is we get a bond of between the nitrogen and the carbon from the carboxylic acid. The CH2 4 times remains the same, C double bond O, like that, and this nitrogen has a hydrogen on it. So this bond here, the NH C double bond O, is an amide bond. That bond, the NH C double bond O, is an amide bond. Complete the equation, complete the polymer, brackets around the outside, right N. The question then goes on to say a section of each of a protein is hydrolyzed. The organic products are separated by chromatography, and each organic product had its pH adjusted to its isoelectric point to form a zwitterion. A selection of the protein is shown below. In the boxes below, draw the protein structures of the zwitterions formed from this section of the protein. So we're going to look for which bonds are we going to break, which bonds are going to hydrolyse, what are the products going to be? Well, just as in this part, we took a carboxylic acid and an amine, reacted them to get an amide. This question is asking you to do the opposite. It's asking you to break an amide bond to get a carboxylic acid and an amine. So which bonds are we going to break? We're going to break the amide bond there. And we're going to replace this half of the molecule and turn it into a carboxylic acid, and this half of the molecule and turn it into an amine. So this half is going to become an amine. C is that atom there. H, OH, CH3, C, double bond O, and remember we form an amide from a carboxylic acid and an amine. Going over to this side of the molecule, this is this one, NH3 plus, C is that one, CH2 4 times, NH2, and then this part here would continue. If you imagine you're drawing it, you'd have a nitrogen there, but we just concatenate it, we chop it off because that end links onto an end like that. So this part here becomes your carboxylic acid. The question ends by saying the isoelectric points of the zwitterions are pH 5.6 and pH 9.6. Explain why these isoelectric points are at different pH values. So what's the difference between this molecule and this molecule in terms of why is one more basic than the other? The difference is in the side chain. So this compound, what type of group does it have in the side chain? It has a basic NH2 group in the side chain. And because of that, it has a different isoelectric point.